From the 7th chapter Integrals, exercise 7.2, we have completed 10 questions. You can watch my previous videos on to learn how to apply, when to apply, and what are the tricks and techniques that we have to know before applying substitution method. Let us solve 11th one. The question is integral of x divided by square root of x plus 4 with respect to x. So here let x plus 4 is equal to t. So we have taken the entire denominator equal to t. Let us differentiate with respect to x. So if we differentiate with respect to x, derivative of x is 1, and if we differentiate t, we will get dt by dx. So now this will be dx is equal to dt. Now let us write in the given question, let us substitute. So in the denominator we will write square root of t, and in the place of dx we will write dt. But what we have to write in the place of x? So if we observe here, x plus 4 is equal to t, right? So this implies x will be equal to t minus 4. So in the numerator we can write t minus 4. Integral of, here we have t minus 4 by square root of t. This is in the form of a minus b by c. So when we have a minus b by c, we can write it as a by c minus b by c. So we have same denominator, right? So this is how we subtract two fractions with the same denominator. So here we have the LCM is square root of t. So we can write this as t by square root of t with respect to t minus integral of 4 by square root of t with respect to t. Now this implies integral of t divided by square root of t can be written as t to the power 1 by 2 with respect to t minus integral of 4 divided by t to the power 1 by 2 with respect to t. This implies integral of t. So here we have t to the power 1 by 2 in the denominator and here also in the denominator. So from the law of exponents, when we have 1 by a to the power m, we can write it as a to the power minus m. So let us apply this here. So then you will get t to the power minus 1 by 2 because we have positive 1 by 2 here. So when it goes to the numerator, it becomes minus 1 by 2 with respect to t minus. So we will take 4 outside, integral of t to the power minus 1 by 2 with respect to t. Now this implies integral of, we have t into t to the power minus 1 by 2. So we can also write 1 here because see, t to the power 1 is t. So here we have the same base. So from the law of exponents, when we have same base, a to the power m into a to the power n. So product of the same base, then we can write it as a to the power m plus n. So we will write t to the power 1 minus 1 by 2 with respect to t minus 4 into integral of t to the power minus 1 by 2 with respect to t. Now this implies integral of t to the power 1 minus 1 by 2 is 1 by 2 minus 4 into t to the power minus 1 by 2 with respect to t. So now both the terms are ready. We can do the integration. Now this implies, so integral of t to the power 1 by 2, integral of t to the power minus 1 by 2. So we know the formula, right? Integral of x power n formula. So here we can write it as t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 minus 4 into. So again t to the power minus 1 by 2, we will apply x power n formula, which is x power n plus 1 by n plus 1. So this will be t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. We have done the integration, so we will write plus c. Now this implies t to the power of 1 by 2 plus 1 is 3 by 2 divided by again 3 by 2 minus 4 into t to the power minus 1 by 2 plus 1 is 1 by 2 and in the denominator also 1 by 2 plus C. Now this implies, so here we have t to the power 3 by 2. So here you have fraction in the bottom, right? Fraction in the bottom. So this type of fractions are called complex fractions. So when we have 1 by a by b, we write it as b by a. So here you can think as 1 by a by b. So then that will be equal to b by a. Okay, minus 4 into t to the power 1 by 2. So again 1 divided by a by b. So you will get b by a plus c. Now this implies 2 by 3 t to the power 3 by 2 minus 4 times 2 is 8 t to the power 1 by 2 plus c. Now this is an important step. To simplify further, we have to take common here. So how to take common? We have 2 by 3 t to the power 3 by 2 and 8 t to the power 1 by 2. If the numbers were simple like 2, 4, we could have taken the common very easily. But here we have fractions, right? And here also we have exponents. So let us learn how to take common. For that we should compare the numbers. So let us compare 2 by 3 and 8. So if you compare 2 by 3 and 8, which one is the smaller here? Here 2 by 3 is the smallest number compared to 8, right? So we have to take 2 by 3 as common from this term as well as from this term. Okay, now let us compare the exponential form, that is t to the power 3 by 2 and t to the power 1 by 2. So which one is smaller here? So if you compare 3 by 2 and 1 by 2, obviously 1 by 2 is lesser, right? 3 by 2 is more. It is half plus 1. It is more. But this is just half, right? So this one is lesser. So we can take t to the power 1 by 2. So which is the term that we can take common now? 2 by 3 t to the power 1 by 2 from both the terms. So this is the thing that we have to take as common. Okay. So 2 by 3 t to the power 1 by 2. We will divide this by this. And the quotient that we get is what we are going to write here. Okay. So 2 by 3 t to the power 3 by 2 divided by 2 by 3 t to the power 1 by 2. So 2 by 3 and 2 by 3 will get cancelled. So we will get t to the power 3 by 2 divided by t to the power 1 by 2. Now this is equal to t to the power 3 by 2 into t to the power of, here we have 1 by 2. So we will write here minus 1 by 2. Now this is equal to t to the power of 3 by 2 minus 1 by 2. And again t to the power of 2 to 3 minus 1. So which is t to the power 2 by 2, which is t to the power 1 and which is t. So here we have to write t. Now if you multiply this, you will get back the term. Now we will divide this divided by this, so that we can write the term here. 8 into t to the power 1 by 2 divided by 2 by 3 t to the power 1 by 2 is equal to, so t to the power 1 by 2, t to the power 1 by 2 will be 1. So we will get 8 divided by 2 by 3. Now this is a complex fraction. So here we have written, so when we have 1 by a by b, we write it as b by a. So here we have 8 into, so 1 by a by b, so we will write this as b by a. So if you simplify, you will get 12. So here we have to write 12. Now this implies 2 by 3. So we know that t is equal to x plus 4, right? So x plus 4. So here we have to the power half. So instead we can write square root of x power 4. And t is equal to x plus 4. So you can observe here, x plus 4 is equal to t, right? So we will write x plus 4 minus 12 plus c. Now this implies 2 by 3 into square root of x plus 4 into x minus 8 plus c. So this is the required integral of the given function.